Alright, we're back. Had some days off. Yep, and we're gonna jump right into it, because why not? Still a little bit sick. Gonna keep the mic off unless I feel I have something important to say. Yep.
We are going to make our spinning donut animation look a little more interesting with some lively floating particles in the background and make them sprinkles. Something else you could use to liven up your renders is Polygon. Try downloading these rocks and then using them in this tutorial to make some floating rocks over an alien terrain. Join Polygon by clicking the link in the description. And I will say, by the way, for this beginner series, this is kind of what I would say a step above what I would normally consider as beginner level. We're going to use some math and get a little more technical in geometry nodes to pull this off. But this is optional. You don't have to follow this video. If you find you get stuck at anywhere in this video and you're like, I don't know what to do, you can just move on to the next one. Just delete it. You'll move on to the next one because it's not going to affect the final outcome. It's just something that's like a bonus nice to have that I thought I'd include in the series. But yeah, anyways, let's go. So we want to have points, some particles, right? But to do that, we need some object for it to start on. And for that, I'm going to use a plane. And I'll just position this at the back. You can play with it later on. And now let's go to the Geometry Nodes tab, which again, if you don't have, just go plus General Geometry Nodes, and you'll see it there. Okay, so let's move out. And just to tidy it up, I'll just hide my lamp and this extra camera. Okay, cool. Now I've got this here, but that's just the icing that is, because we clicked pin, it'll show up no matter what object I've got selected. So just unpin it, and then you'll have new. So click new, and now we can start doing our magic. Haha. So let me just move this over so we've got a little bit more room. All right, cool. Let's get started. So to create points, we need to distribute points, and you do that with points, distribute points on faces. Okay, we do that, and now our solid plane becomes just a series of points which are randomly distributed, which is cool. Okay, now we want to change the starting position of these, because obviously they're all just on a flat plane, which isn't ideal. So to do that, we're going to use a set position node, and I can never remember where it is. Oh, there it is, geometry, set position, or you could also find it just by typing in set under search. But anyways, geometry, set position, drop that in here. And now this offset here, you can see we could play around with the three axes, the X, the Y, and the Z, and we could change, we could change those values. But as you can see, they're all sticking as a whole, which is not what we want. We want each point to be independent. So to do that, how would we create random independent points? We would use our good old trusty random value node, which is quickly becoming my favorite node. Or more so just like the node that I end up using all the time. If we used this and plugged this into our offset, you would see this happen. Each of those points is now somewhere between 0 and 1 on all three axes, the X, the Y, and the Z. So it's adding similarly to like if we were just make all of these 1, you can see that it's in the general like diagonal direction because that's what a plus value on each axis kind of looks like. Okay, so it's doing the right thing, but it's doing it on all three axes, and we don't really want that. So we're going to change it from float to vector. And instead of giving us just 1, it's giving us 3 axes, X, Y, and Z. The start, the min, and the max. Okay, so if we put this into the offset, you can see we now have more control. If I set this max value to 0 just by dragging down on all the fields, then it hits 0. This is the exact same as what we had before. There's no variation happening here. But if I increased just the Z, which is the bottom one, it doesn't show it, but it's X, Y, and Z. It's always in that order. The bottom one, if I just increase that, you can see that I'm changing where each of those points appear. Okay, so I'm sort of creating this little imaginary volume. Okay, so that's the X. And then if I wanted it to influence the Y, okay, and sort of expand the shape of my volume going backwards, I could do that and then drag it over. And if I wanted it to start, down here, then I would make my minimum value have a minus value. Okay, so it's now going downwards because it's basing the 0 value off of where it starts, which is like here. Oh, to start sort of creating this little imaginary volume. Okay, so that's the X. And then if I wanted it to influence the Y, okay, and sort of expand the shape of my volume going backwards. I could do that, and then drag it over. And if I wanted it to start, down here, then I would make my minimum value have a minus value. Okay, so it's now going downwards because it's basing the 0 value off of where it starts, which is like here. Oh, yeah, I don't know why I just instinctively Control-Shift-Click in geometry nodes, but the viewer doesn't seem to do anything yet for that add-on, the Node Wrangler add-on. But anyways, the 0 value is based on where it starts, which is there. So it's just a minus value. We'll put it underneath it. Okay, so that's kind of, we've given it a thing. But if we hit play, nothing's happening. These points are not moving until we tell it to move, and that's what we're going to do. So to tell it to move, we're going to duplicate our set position node and place it straight after. So Shift D and then drop it straight after. And now you could see, just dragging this value here, I could change this, right? In fact, very easy to create a snow animation now. If I added a keyframe on this point, which I didn't mention really in the animation one, but the I, hitting I to insert a keyframe, it works in any field. So if you hover over any field in Blender and you just hit I, you can see it's gone yellow to say this is now a keyframe on this point. And then if I went to the end point of my animation, which I could do by Shift right arrow, you can see I'm now on frame 300, and then put this all the way down here and then hit I again. Back at the start, hit spacebar to play it. You can see they're all falling. So look, it's snow, magical, ta-da. But a problem with this, for one, it's got that annoying slow down and then ramp up at the start of it because the animation is set to Bezier. So I would have to change it here if I'd have to change that to vector, which I guess is easy to do. But also, it's all moving as one. So I don't want this. So let me just right click and say clear keyframes, and that'll remove all my keyframes. Yeah, I don't want that. By the way, just quickly, because I thought it'd be cool to mention, the thing where you can hover over any value, you can do it for colors as well. You can do it for any value. So if I had my donut or my icing here and I hit I on the base color and then I moved to the last frame and then I went green and then hit I again. If you played back the animation, did I hit I? Okay, it's working. All right. You can see that it would change color throughout an animation. So anyway, I just thought it was cool to mention because it is a cool feature of Blender that you can quickly add a keyframe anywhere. It doesn't matter. It's just kind of a cool thing. Anyways, sorry to detour there. Okay, so I don't want to use the keyframes because it's all moving independently as one. Instead, I want to use math, okay? So keyframing, it's really if you look at, what we had for our rotation, right? At this point to this, we play it back, right? This thing is changing, but it's just every single frame, it's saying update it to this new rotation, update to this thing. There's nothing that's really tying it together. It's just saying this frame correlates with this value, this frame correlates with this value, and your mind is creating the illusion of rotation. Well, with this, there's no reason we need to use keyframes for this. And in this case, it's actually good because we want to make random values. We don't want to make them all move as one. We want to give them different values. So we could actually take our frame value that's displayed up there, and if we could put this into this geometry nodes here, then we could use math to influence it, and we don't have to use keyframes. It's actually a lot easier to work with. So trust me, it is better. It's cooler. The way that we put a frame value into it is, first of all, Shift A, and then let's go Input, and then use value. Okay, so value is the simplest node in geometry nodes probably. You'll also find it in shading and everything else. It's just a single value. But what you can do is you can type in #frame. Haha. Now, if I play back my animation, you can see that value is changing with the frame. Okay, so hashtag is, by the way, kind of a way of adding in a driver. So you can say that when it goes purple, that means there's a driver on. So this value here is being driven by something else. That's what Blender's telling you when it's purple. So kind of you can't change it. It's being influenced by something else, which is defined by what it is when you click it. So frame. Okay, so now watch what happens. If we take this and we put this into our offset, can you guess what will happen if we play it back? Try to guess. Think about it. It's going to go... It's going to shoot off into the stratosphere. Away! Now, the reason that's happening, as some of you might have figured out, is that let's say we're on frame 10, okay? It's assigning a value of 10 to each 3 of these axes. So it'll be in the exact same position as if we entered in 10, okay? Like that. That's what it's doing. Okay, so that's obviously, that's cool, but it's not what we want. We don't want it shooting off in one diagonal direction. We want to define which axis has which amount. So we can do that by separating these things, which oddly enough you do with a combine node, which I guess is true. But anyways, type in combine and you'll see combine XYZ come up, which by the way, it's a search. So Shift A, search, I use it all the time because I can never find the one. Anyway, combine XYZ. If we put this into here, this, by the way, will give us the, oops. Okay, if we put this into here, nothing will change. If these are set to 0 and this is set to 0, it's the nothing will have changed. The advantage that having this plugged into here is that you now get individual inputs over here, which you don't get over here. You can see this just gives you one solid value for all 3 of those. So if this node was set up to have 3 independent inputs for the XYZ, you wouldn't need this node, but it just gives you one, so we're just going to use that. Okay, so now I could say, take this and put this into just the Z axis. So now the same thing is going to happen, but it's just going to shoot in one direction, which is up, because it is adding a 1 plus value. So it's moving it in one single Blender unit for every single frame along the Z axis. And it's going up because that is the direction of positive. If it was downwards, if it was negative, it would be going downwards. Okay. So that's pretty cool, but it's moving too fast. All right, we'll get to the flipping the direction around, making it go downwards, but it's moving too fast. Let's say we're on frame 10, okay? And let's say we want it to be half the speed of what it is. So basically on frame 10, we don't want it to be up here. We want it to be right about here. Well, this is where you can get into math. Now, I'm not a good mathematician. My dad is, funnily enough. As I think I mentioned in previous parts, I almost failed math. And now I'm like calling my dad on the phone, asking him math problems, which is kind of funny. He thinks it's funny because, yeah, I just hated math. And now that I'm using Blender, I'm like into it. But this is really simple. How do we change the position of this to be half of what it is, right? What would the math for that be? To change it to half, it would be divided by 2. So for this, we can do a simple math calculation by hitting Shift A. But this is really simple. How do we change the position of this to be half of what it is, right? What would the math for that be? To change it to half, it would be divided by 2. So for this, we can do a simple math calculation by hitting Shift A, Utilities, Math, which is also a very common, convenient node, which you can use for all sorts of equations. And we want to use divide. So divide by what? 2. And you can see it's roughly where I drew it. But now it's not up where it was. It's now halfway between it. So this is now moving at half the speed that it was. So obviously, if I wanted to make it move even slower, all I would have to do would be to increase that division amount. And what's cool about this, and this is why it's kind of it's nice to not be dealing with keyframes, is that I can play with these values in real time. I don't have to worry about like what keyframe I'm on. I don't have to deal with, you know, going in here and dealing with the F-curve modifier and changing things. It's all done with math, and it's quite fun once you figure it out. But I know that it's not, you know, native, I guess. I mean, there's a reason a lot of us are using Blender for 3D art, not 3D programming. We were attracted to the creative field, not the mathematical. But it's pretty simple, and once you get the hang of it, it's like, oh, this is kind of fun. At least I think so. So that's great. So we've slowed it down. How would we make it go in the opposite direction? Very simple. Just add a minus, and now it's going in the other direction. Haha. Very cool. So that is how you'd make snow, right? We haven't solved for like how to make it move independently each one, but we're getting there. Okay, now something that is kind of handy to know or handy to do when you're starting to build out geometry nodes and you've got a lot that's going on. In the future, you might, you'll be playing with shading, you'll come in here and you'll do a bunch of stuff, and then like, a couple of days later, you'll come back to geometry nodes and you'll go like, yeah, I want to change the speed of this. And then you'll be like, which one of these changes the speed of, and you'll forget. So it's helpful to comment on something, which is what programmers do. They do a comment and you type in what it is. So in the future, you come back to it and you know which code does what. So we can do that with a node selected. If I hit Control J, you can see that it's created this little black boundary box around this. Um, it's adding a frame, which you can do at any point just by going to Layout Frame and then just dropping it over any node and then just select the node, move it into that frame, hit it, and then you'll make the little box appear. But you can do it over multiple nodes, Control J, etc. So we can do that with a node selected. If I hit Control J, you can see that it's created this little black boundary box around this. It's adding a frame, which you can do at any point just by going to Layout Frame and then just dropping it over any node and then just select the node, move it into that frame, hit it, and then you'll make the little box appear. But you can do it over multiple nodes, Control J, etc. But anyways, so Control J is the hotkey to create a frame over it. And then if I hit N on my, bring up the properties, N, and then go to Node, so it's the selected node, which is the frame, then I've got Label. And I could type in anything and you can see it appears right there. So I'm going to type in speed of animation so that in the future, when I come back to it, I go, where's my speed? Oh, it's right here. And then I might remember like, oh, what does this node do? You know, this is frame value, something like that, you know, if I wanted to. Okay. So I also want this to not just move downwards. I also want it to move like it's blowing leftwards as well. So I'm going to drag this and also make it influence the X value. Okay, so now it's going left. And it's just coincidence, pure coincidence, that it's the direction that I want it because of it's going in the opposite direction of X, which is left. But if we're not just move downwards, I also want it to move like it's blowing leftwards as well. So I'm going to drag this and also make it influence the X value. Okay, so now it's going left. And it's just coincidence, pure coincidence, that it's the direction that I want it because of it's going in the opposite direction of X, which is left. But if, for example, I wanted it to move in the opposite, like make it go not right to left, but left to right, the other direction, I would just use another math node and just swap it from from negative to positive by going multiply -1, and then now it's doing it the opposite direction. So 1, this is the default direction, and then -1 puts it in the other direction. So it's math. Hey, math, isn't math fun? Anyways, cool. So we are getting there. All right, let's move this over. All right, so how do we make it so that each one of these particles is not moving collectively like a flock of birds, but each of them having a random value? There's the trick. There's the key there. Random value. So we're going to add in our trusty random value node. Drop this in here. And what we want to do is between here and here, I want to have this influence it. So the way I'm going to do that is by adding another math node and say math, drop this in here. And let's do it for both of them, the x and the y. And to influence something and have this sort of multiply this value, you would set this to multiply. Multiply is, I don't know, it's like my go-to when I'm like, what would the math equation for this to, it's multiply. But anyways, I'm going to take this and put this into here. Now watch what happens. Ooh, not much. But when I play it, ha, each of these points are now affected individually by a random value. So some of them are moving this value, you would set this to multiply. Multiply is, I don't know, it's like my go-to when I'm like, what would the math equation for this to, it's multiply. But anyways, I'm going to take this and put this into here. Now watch what happens. Ooh, not much. But when I play it, multiply this value, you would set this to multiply. Multiply is, I don't know, it's like my go-to when I'm like, what would the math equation for this to, it's multiply. But anyways, I'm going to take this and put this into here. Now watch what happens. Ooh, not much. But when I play it, ha, each of these points are now affected individually by a random value. So some of them are moving at its like almost its full speed at like 1. Some of them are barely moving at all because they're like probably close to the 0 value. And then most of them are somewhere in between that value, right? So they're all moving independently, which is cool. And what's great about this is whilst it's playing, I could say, you know, these ones that are static don't look good. I want all of them to at least move at like half speed. So like 0.5, okay? And then maybe, you know, I could like dial this one backwards. But I can change sort of like how close they move together very easily with this in real time, which is like, it's really cool. It's quite fun. Who would have thought math was fun? Okay, cool. So that's how we do that. Ta-da! So we've got the movement right. And if I ever wanted to, you know, yeah, I'll come back to this. Let's say I'll add another little frame here. And let's say this variance of speed, animation speed. Let's say variance of animation speed, so I can remember it. Right. Okay. So now let's put the sprinkles. Let's make each of these points, which would not render. If you hit render, you wouldn't see anything because it's just data that's stored in Blender. It's not actually being used for any rendering purpose. For that, we need to first of all add in a point. Nope. Instances on points, not 2 points, on points. They're both next to each other, and put this in here. And now they've disappeared because we've said convert those points to instances, and there's nothing in the instance. So for that, I'm going to drag the object, or collection in this case, down here. So my sprinkles, click, drag, move it down here, just like we did for our icing, and then take this, put this into the instance, and I'm going to click pick instance, separate children, and reset children. So you click all 3 of those checkboxes whenever you're using collections on points, essentially. They have uses beyond, you know, but like if you had like multiple points that you wanted to be like part of a grass system, each item in a collection was a single object, you wouldn't say separate children, I guess. Anyways, doesn't matter. All right, Cool. So I'll just check, by the way, that my plane is okay. All the scale is at 1. If not, I would apply the scale. And then my scale here, like these are like they are showing up, but they're really, really tiny. So I'm just going to increase this, clicking and then dragging to the right. Or I could just type in a value, 6 or something like that. Okay, cool. So it's working, but they are all the exact same rotation, so that's not good. So we want to add in what? We want to add in our trusty random value node. So yeah, let's go over here. Utilities, random value, drop this in. If we put this into rotation input, you can see they're all rotating, but on all 3 axes at the same point. So let's change it from float to vector and then re-plug it in to rotation. Now we're getting somewhere. Now, as you might remember from the previous points on the icing, when you want to rotate something, this value here, it's not degrees. So it's, you would think it's degrees, but it's not. It's actually radians, which go into the pi and the constant and all that kind of thing. Pi is half a circle, half a rotation, which is 3.14, whatever, which you could do by typing in pi, but you want double that to get to the full rotation, 360 rotation, which is tau, T-A-U, tau. But also you could just, any value above 6 and you'll be there. And you could also say minus tau and then the starting, and then it would be like really random. Anyways, so now their starting rotation point, they are all on a different axis. So that's pretty cool, and that's not bad. But let's say also, we don't just want them to start at a random rotation, we also want them to move independently as the animation is playing. That would be cool. And the way we're going to do that is with our favorite pronounced node, rotate Euler node, and we're going to drop this in here. So you could see I could rotate each of these along an x-axis, a y-axis, etc. Now we would want to give a random value to each of these rotations, driven by this value over here, and that would be kind of tricky. We could plug this into here. We can see they're all just kind of shooting around at like a random axis, and it's not ideal. Instead, if I change the axis, from Euler to axis angle, you'll get this little angle field at the bottom there, okay, which is kind of handy. If I take that now and drag that into there, we can now actually control which axes get which influence by this axis. So the 0 and 1, think of it as like a 0 to 100 percentage. So 1 is getting 100% of this angle rotation, and then 0 is getting none. So if I set them all to 1, they're all getting the exact same rotation, and I could say, not the x, more of the y, or something like that. But anyways, in this case, we actually just want them to be all 1, so I'll set them to 1. Okay, so they're all moving too fast. So what do we do? do? What do we do when we want to slow it down?
Very, very lost.
We use a divide calculation. Now, and drag that into there, we can now actually control which axes get by this value over here. And that would be kind of tricky. Like, I mean, we could plug this into here. We can see that we're just kind of shooting around at like a random axis, and it's not ideal. Instead, if I change the axis, from Euler to axis angle by this value over here. And that would be kind of tricky. Like, I mean, we could plug this into here. We can see that we're just kind of shooting around at like a random axis, and it's not ideal. Instead, if I change the axis, from Euler to axis angle, you'll get this little angle field at the bottom there, okay, which is kind of handy. If I take that now, and drag that into there, we can now actually control which axes get which influence by this axis. So the 0 and 1, think of it as like a 0 to 100 percentage. So 1 is getting 100% of this angle rotation, and then 0 is getting none. So if I set them all to 1, they're all getting the exact same rotation, and I could say, not the x, more of the y, or something like that. But anyways, in this case, we actually just want them to be all 1, so I'll set them to 1. Okay, so they're all moving too fast. So what do we do? What do we do when we want to slow it down? We use a divide. Calculation.